this short section, we're going to cover significant figures. Significant figures or significant digits are the number of digits required when writing a number to a required degree of accuracy. An odd definition, but it'll make more sense when we start getting into the examples, I think. When we're trying to determine the number of significant figures in a number, there are a few rules we have to look at. First rule, any non-zero digit is significant. So if any 1 through 9 digit counts as a significant digit. Rule number 2, any zeros between two significant digits are also significant. So if we have a 0 between a 1 and a 5, then that 0 counts as a significant digit. A final 0, any trailing zeros, are significant only if they are after the decimal point. So a number like 100, the 2 zeros are before the decimal, so they don't count as significant figures. But a number like 9.00, the 2 zeros count as significant because they follow the decimal point. So again, the easiest way to learn these things is just by seeing a few examples. So let's look and find the number of significant figures in each of the following values. Number 12,370, any non-zero number is a significant digit, so the 1, the 2, the 3, and the 7 automatically are significant digits. The zeros are significant if they're between two other significant digits or if they're after a decimal. This 0 is neither of those things. There's no significant digit over to the right, and there's no decimal before the 0, so the 0 does not count. So the only significant digits in this number are the 1, 2, 3, and 7, so we have 4. There we go. 4 significant digits. So the number 100,890, looking over here. Right away we know the 1, the 8, and the 9. Any zeros between two significant numbers, so the 1 and the 8 are significant, so that makes the 2 zeros between there significant. This 0 is not significant because it's not after the decimal and it's not between two. So we have 1, 2, 3, 4, 5 significant digits. First thing we do is count the non-zeros. So 1, 2, 3. All of these zeros are after the decimal point, so all of them count. So 1, 2, 3, 4, 5, 6, 7. This one is 12.30000 has 7 significant digits. Every digit in that was significant. 150,000. Remember the decimal, if we don't have one, is at the end. Start with our non-zero numbers and count them. None of these zeros are between non-zero numbers, and none of these zeros are after the decimal, so none of them count. So this one, 150,000, only has 2 significant digits. 2,500.09. Let's look at our non-zero numbers first. All 3 of these zeros are between the 5 and the 9, so all 3 of these zeros count. So now I have 1, 2, 3, 4, 5, 6 significant digits there, all of them counted. 11.20, my 1, my 1, my 2. This 0 is not between two non-zero numbers, but it is after the decimal point, so it also counts. So here we have 4 significant digits. Significant digits are kind of an easier thing to understand once you start knowing which zeros to count and which to leave out. Mainly all you're looking for are the zeros between non-zero numbers and the zeros after decimals. And again, the main reason for this is to talk about how precise a number is. This, for instance, this 12.30000 is estimated rounded to this last 0. This number, however, we could only say is rounded to the nearest 10,000. We can't say it's rounded down to here. It might be rounded up to here because those zeros aren't significant. So it's really just in determining how precise an estimation is. So this number is more precise than, well, this number is more precise than this number, it has more significance.